Solve using any method. Your methods that you could use are the following three. You could use factoring. If it works, you could use the quadratic formula. That always works. Or you could use the square root property. That works only in certain situations. So you can try factoring. If that doesn't work, you can use the quadratic formula. So in any method you try to use, you need to make sure that you have an equals 0 in this equation. So I want to subtract 16 x's and I want to subtract 36 from both sides. And when you do that, you'll end up with an equation that looks like this. Cancel those, and you'll end up with x squared minus 16x minus 36 equals 0. And I'm going to check factoring, because if I can factor this, then I know the solving will be much easier to do from there. So I'm going to use the little table here, and a times c is negative 36, that's 1 times negative 36, and b is equal to negative 16. And so I know the pairs of numbers that multiply to negative 36 are 1 and 36. I know they're going to be 2 and 18. I know it's going to be 3 and 12, 4 and 9, and 6 times 6 will also give me 36. Now you may notice I didn't put any negatives in here yet, because I want to have a good idea as to which number, if it's going to be the larger number or the smaller number that gets the negative. So whatever it is, these two numbers, these pairs, they need to add up to something negative. That means we need to take away the larger number. So the larger number here will be negative in each pair. And in this last example is kind of weird. One number isn't larger than the other, so we can just assign the negative to either one. So we have these pairs that will give us negative 36 when we multiply. Which pair of these numbers adds up to negative 16? It's this one. So we found 2 and negative 18 to factor this over here. And when you end up going through all the steps of factoring, this will look like x minus 18 times x plus 2. And that equals 0. And by the zero product property, we can set each of these equal to 0 and get that x equals 18 and x equals negative 2. So there are your answers for this quadratic equation. Solve using any method. In the previous example, you were given 3 different methods to solve a quadratic equation: factoring, quadratic formula, and the square root property. I think it's always a good idea to check if factoring will work first, because if it does, then the solving becomes very easy. And a times c, so we can figure out what numbers we need. A times c, 3 times 4 is 12, and b is negative 8. So I know two numbers that multiply to give me 12 will be 1 and 12, 2 and 6, 3 and 4. I think those are the only pairs. And as they are right now, when we add these two numbers together to see if we can get negative 8, we will get only positive numbers. So as these are, these will not work for us. It turns out that if you are getting a positive product, there are 2 ways to do that. You can do that if both numbers are positive or if both numbers are negative. And in this case, we need both numbers to be negative because when we add them together, we need to have a negative sum. So -1 times -12, -2 times -6, and -3 times -4. Which pair of numbers adds up to -8? It is -2 plus -6. So you can come over here and do your splitting of these things. So this would be -2x plus, -6x. There we go. Plus 4 plus 3x squared equals 0. You can do your common factor from each pair. So from here and from here, and it'll look something like this. So in this first pair of terms, I've common factored out an x, and I got 3x minus 2 left over. And I knew that I needed a 3x minus 2 over here if I wanted to factor it the right way. So then I just had to figure out what number times 3x will give me -6x, and that's -2. And just as a double check to make sure -2 works, -2 times -2 is +4. So we have an x minus 2 there. That's awesome. The next step is to do another common factor of 3x minus 2. And when we do that, and we essentially cover these terms up, what we have left is an x minus 2 left over. So now we can set each of these equal to 0 to get x equals 2/3 and x equals 2. Here are your answers for this quadratic equation. Graph 2x minus 3y equals 9. This is a linear function, and it's always the easiest thing to do to graph once we have solved for y. So in order to solve this for y, I'm going to subtract 2x from both sides, and that will leave us with -3y equals -2x plus 9. The last step here to solve for y is to divide by the coefficient on y. So the negative is still here, right? We only subtracted 2x. We didn't affect anything in this -3y. So here we have to divide by -3. This will reduce to 1, and we'll be left with y equals -2 divided by -3 is a +2/3x. +9 divided by -3 is -3. So what's important about solving for y so we can graph is that this number, the constant, gives us our y-intercept, and that is going to be 0, -3. So we can come over here to the graph and plot that point at 0, -3. That's our starting point. That is, we're always going to be starting somewhere on the y-axis with a linear function. So when you solve it for y, that gives you the starting point. Now, this number, 2/3, that is the slope. Now, if you have a positive slope, the top number tells you how far up to go. If you have a negative slope, then the top number tells you how far down to go. The bottom number always tells you how far right to go. So over here on the graph, I'm going to start at the y-intercept here in blue, and I'm going to go up 1, 2. Because when I look back over here at my slope, it's telling me to go up 2. That's what the top number tells me. So I went up 2, and now if I look at the bottom half of the slope, this 3, it's telling me to go right 3. So I went up 2, right 1, 2, 3. I'm going to put a big dot there. And now I'm just going to repeat that pattern. So I'm going to go up 1, 2, I'm going to go right 1, 2, 3. Now I'm going to go up 1, up 1, 2, over 1, 2, 3. And just for good measure, I want to go the other direction. So the whole pattern I was following over here, up 2, right 3, up 2, right 3, up 2, right 3, I'm going to go completely backward. I'm going to go down to left 3. So I'm going to start back here at the red dot. I'm going to go down 1, 2, and left 1, 2, 3. And I'm going to put a big dot there. And you can continue that pattern until you run out of graph or until you feel like you've got a good enough pattern showing on your graph. So then we have all these points. The last step is to connect them like this. There's your graph of the linear function. Graph. F of x equals x squared plus 2x minus 8. This is a quadratic function. You can tell because there's a square. The number in front of the x squared, the coefficient of x squared, tells you whether or not this graph will open up or down. And if a is positive, then the graph will open up. And if a is negative, the graph will open down. Well, it turns out here, this number in front of x squared is 1, and it's positive. So we know this graph will open up. And that'll help us when we get over here and start graphing that quadratic function. The next thing we need to do is find the vertex. And the first part of that is finding negative b over 2a. So we have to come back up here and know that b is positive 2 and that a is positive 1. So I'm going to just put it up there in blue. A is 1. So when you substitute those numbers in here, you'll get back that the x-coordinate of the vertex is negative 1. So the vertex is an ordered pair. So we need an x-coordinate and a y-coordinate. So all we have is an x. How the heck are you supposed to figure out the y-coordinate? Well, the way to do it is to take your x-coordinate and put it back up here into the function to get back a y value. So when you do that, you find f of negative 1. And when you do that, and you put that number in here for x and in here for x and simplify everything out, you get negative 9. So that's the y-coordinate. So the vertex as an ordered pair will be x comma y, negative 1 comma negative 9. The y-intercept happens when x equals 0. So when x equals 0, that just means you substitute x in for 0 in for every x up here, and you'll get back a y-coordinate that is negative 8. So the y-intercept will be 0, negative 8, and one other point, we'll get to that in just a moment. So what I want to do now is plot these. I'm going to put the vertex right where it's supposed to be, negative 1, comma 9 right there, and I'm going to label that with V for vertex, and I'm going to put in the y-intercept over here in blue. Let me mark that vertex as being red. There we go. Now the y-intercept I'm going to put here in blue, and some things to remember about a quadratic graph is that it'll either have a maximum value or a minimum value. And since this graph opens up, there will be a minimum value. You can see it, it's right there. That vertex will be a minimum value. And that makes sense. If you look over here, the vertex is the lowest point. The y-intercept is a little bit above that on the graph, so that makes sense. This is going to open up. So back over here, the other point, there are a couple different things you could do for this other point. You could find the x-intercepts. and that is when you set f of x equal to 0. So f of x is this quadratic expression here. So that means you could set x squared plus 2x minus 8 equal to 0 and do some factoring and get that x equals -4 and x equals 2. So now you just found two x-intercepts. Instead of one other point, you found two other points. So that's one thing you can do. Another thing you can do is you can remember that the vertex has an axis of symmetry, a vertical axis of symmetry that runs through it. And we call this an axis of symmetry because the points on the right side will mirror the points on the left side. If you take a look at this x-intercept is 1, 2, 3 away from the axis of symmetry. This x-intercept is 1, 2, 3 units away from the axis of symmetry. But that requires some extra work figuring this out. Instead of finding the x-intercepts, we could have gone ahead and found a mirrored point like this. This y-intercept, or this point on the parabola, is 1 unit away from the axis of symmetry. So we could mirror that over here because this point is also at the same height and 1 unit away from the axis of symmetry. So here we go with the final graph. I'm going to do it in blue. It'll look something like this. Yeah, there we go. So there's the graph of your quadratic function. Graph. F of x equals the square root of x plus 2 minus 3. What you need to remember with this is that whenever you see a number being added or subtracted in grouping symbols with x, that it'll do the opposite. So this right now is telling me that this is going to go left 2 units. It looks like we want to go right 2 units because positive 2 is over here, but x's are crazy. Do the opposite, go left 2 units. Any number not grouped up with x, like this -3, will either tell you to go up or down. And if it's positive, it'll go up, and if it's negative, it'll go down. So our starting point will be left 2, down 3. So we always start here. That's where my starting point should be, but now it's moving left 2, down 3. So I'm going to move it left 2, down 3. Here's my starting point in blue. From here, the pattern for the square root function is up 1, right 1, and then go up 1 again, right 3. So I'm going to start at my starting point right here, and I'm going to go up 1, right 1, put a point, and from here I'm going to go up 1, right 1, 2, 3, and there's my next point. And that's what my graph looks like right there. Now, the last thing that we need to do here is to find the domain in range. And again, the domain means how far left does this graph start. And in this case, the graph starts when x equals -2. That's exactly how far left it starts. So we're going to say that the domain is -2. And how far right does it go? Oh man, we've got an arrow. Arrow tells us to go all the way to infinity. So we have -2 to infinity. And I'm going to put a bracket around this -2 because there is a solid dot, a closed dot right there. The range, on the other hand, is how low does the graph start. So when you come over here, the lowest point, it's going to be a y value, is -3. So I know this range is going to start at -3. And not only does this arrow tell us to go to the right forever, it's also telling us to go up forever. So the range tells us how low do you start, how high do you go. So it'll go up forever, which means this will be infinity. So here is your graph, and here are the domain and range. Graph. f of x equals negative the absolute value of x minus 1 plus 4. And again, we have this very similar idea as the last graph. Whenever you see a number in grouping symbols with x, in this case it happens to be absolute value, whenever you see a number inside with x, you're going to do the opposite. So it looks like x should be negative 1. It looks like it should move left 1. X's are crazy. They're going to do the other thing. You need to shift this graph to the right one. Then, if you see a number outside, that tells you to move up or down. And if it's a positive number, you're going to move up that many units. So this graph is going to go right 1 and up 4. And then we've got this one last little piece of information here. This is a negative that's being multiplied. And since it is outside of the grouping symbols of x, what that means is that this will reflect over the x-axis. So reflecting over the x-axis means instead of opening up, it will open down. All right, so let me erase these graphs. There we go. The normal parent function for absolute value looks something like this. And I'm going to use x's for right now. I'm going to start with blue x's. It's here. It's 1 to the right, up 1, 1 to the right, up 1, 1 to the left, up 1, 1 to the left, up 1. So it'll have this V shape with a sharp corner right here at 0, 0. So when you reflect over the x-axis, all these points right here will end up being underneath the x-axis. So I'm going to use some red points to, I'll use some green points to represent the reflections. So that one will not move. This one will get reflected over the x-axis there. This one will get reflected over the x-axis there. And similarly with these. The last thing we need to do is to move these points, these green points, up 4 and right 1. So this x will go 1, 2, 3, 4 up, right 1. So there's 1. This x will go 1, 2, 3, 4, and right 1. And we can continue this pattern. So the red dots here are going to be the final graph. The last thing we need to do is find the domain and range of this graph. And it's always easiest to find the domain and range of the graph rather than trying to just do it from an equation. This is not as helpful as seeing this. So I know already that the domain of an absolute value function is in fact all real numbers. So you can write negative infinity to infinity, or you can write the symbol for all real numbers, the double bar R. The range, on the other hand, again tells you how low does this graph start. Well, we've got arrows pointing down in both directions. So this graph is going to start way down at negative infinity. And then, again with the range, it's how high does it go? Well, we have this. This is the top out value. This is the highest point on the whole graph. And that y value is 4. And this is a closed dot, so we can include it in our answer. So here's your graph, and here is the domain and range of this graph.